Welcome. We're going to solve the last of the angles outside the circle problems from your notes. Right, most of these will be in your notes. Might be one or two that's not. So let's look at our first one. This one is in the notes. We have angle ABC is formed by two tangents intersecting outside a circle. The major arcs formed by the two tangents encompass the entire circle. The major arc plus the minor arc equals 360 degrees. And that will always be true when the angle is created by two tangents, because they only touch the circle one time. They intersect in one place. Right? So, but regardless of whether it's two tangents, a tangent and a secant, or two secants, we're going to find the angle by angle is going to be equal to half the large arc minus the small arc. The large arc is always the one that is farther away from the angle. So right here, this would be the large arc. And we know that arc, the large arc, is 260 degrees. Together, the large arc plus the small arc equals the entire circle. So that would be equal to 360 degrees. Since the large arc is 260, if we subtract 260 from both sides, the small arc equals 100 degrees. Right, so 360 minus 260 would be 100 degrees. Right, so now we know both arcs. Right, this one's not too difficult of a problem to solve. Right, so x is going to be equal to 1/2 of the large arc is 260 degrees. The small arc is 100 degrees. Right, so that means that x is equal to 1/2. 260 minus 100 is 160. And that means x equals 80 degrees. Some of these we'll check. I think this one is a little bit of a simpler problem. I don't think we'll check this one. Right? And to check, you just plug it back. You plug the value you get in for x. So we would just plug in 80 for x, and we would make sure that, yes, that's true. But this one you can even like check in your head, right? 80 does equal half of 160. Right? 260 plus 100 would equal the whole circle. Right? And so this appears to check out. All right, let's look at the next problem. And so I may talk about some of the problems we've already done in class if I need to, and some problems I'll just be skipping over because we've already done them either on a Nearpod or in class. And we're just waiting for the next problem to come up. All right, so this was a problem we did in class. We're going to do almost the same problem, except we're going to solve for the other arc. All right, so in this case, we solved for arc AC. Right, so AC was the one we solved for here. And so we find the value of x, that's arc AC. Let's see what it looks like if we solve for the other arc. In that case, we're going to solve for arc ADC. Right, and let's see what that one looks like. All right, so I think you have this one in your notes. Let's take a look at what it looks like when it's the other way around. We're solving for the large arcs. Now we're going to solve for arc ADC. And there are some problems like this one in your notes. Looks like C got erased. Right? So now, first of all, together the two arcs equal the entire circle. Right? We have two tangents. Both arcs, the large arc and the small arc, equal the whole circle. So arc ADC plus arc AC does equal 360 degrees. And I don't remember if we already went over this and I had you put it in your notes, but I wanted to make sure that we did go over this one, even if I had done it once before. Because you will have some problems like where you, like this one in your homework, where you need to solve for the large arc, not the small arc. And if that's the case, it's better to label the large arc with the x. Right? So if together they both equal 360, and we've already labeled arc ADC with an x, if we subtract x from both sides, it means that arc AC is going to get labeled 360 minus x. Right? So this is 360 minus x. And now we're going to set this up just the very same way we did the last problem. Right? So the angle is half large arc minus small arc. The large arc is right here. It is farther away from the angle. That'll always be true. The large arc is further away. The small arc is closer. right? So this one here is the small arc, and this one here is the large arc. Right, so this would be angle B, which, and I'll put in the values. So angle B is equal to 1/2. The large arc is arc ADC minus the small arc, which is AC. Right, so now I'm going to plug in values now. Right, so I said I'm going to plug in values. For angle B, we can plug in the 70. Right, that's the measure of angle B. For arc ADC, we're going to plug in the X. And then for arc AC, very important, we need parentheses here because we're going to distribute that negative because we're subtracting all of AC, and AC is represented by two terms. And so we have to make sure we distribute that negative. So that's going to give us 70 equals 1/2 X minus 360. Negative times a negative is positive, so that'd be plus X. So that's going to be 70 equals 1/2 times X plus X is 2X minus 360. We can distribute the halves since those are both even terms. If they weren't even, we would just multiply both sides by 2. But there's no reason to do that because 2X and 360 are evenly divisible by 2. So 70 equals X minus 180. And then we just add 180 to both sides. So X is 250 degrees. And there we go. We've got that one done. And now if we looked at the other one, so the large arc here was 250 degrees. Let's see what the small arc was. All right, so we had done that one on the previous problem. And any day it's going to come up and show us our answer. Look at that, we got 110. Right, so the small arc was, we got 110. For the large arc, we got 250, right? And here, another way you can find it is once you have found this, if you label X the small arc, once you find the small arc, if you do plug back in the value of X, you can get the large arc, right? So here, we labeled the small arc with X. If I plug in 110 for the X, and I was really looking for the large arc, 360 minus 110 is 250. What we got for X, went over here when we labeled the large arc X. And let's see if we get 110 for the small arc on the next problem, right? So here we found the large arc, right? That was X, right? So that was 250 degrees. And if we plug in 250 for X, we would have 360 minus 250 means that arc AC is 110 degrees. Right? So if you do label the wrong one X, and oops, you look at it, and you solve it all out, and you're like, oops, I was supposed to find arc ADC. Well, you can still find it, right? It just won't be your X, right? You'll have to do something to find it, right? But you can find either arc, no matter which arc you solve for, right? And if you have any questions on this one, this is probably the trickiest of all the problems, just let me know. All right, so I think that's maybe I've got one more two tangent problem before we look at two secants and a tangent and a secant. We have this one, and it says notes, but I don't see this one in your notes. I don't think this one is in your notes. All right, so ignore where it says notes. All right, and we'll do this one. This one is very similar. We're looking for arc DB, and actually, let's look for arc DCB. I changed my mind. All right, so one more time looking for arc DCB. All right, so if you're looking for the large arc, label that one X. All right, that means that this one is going to be 360 minus X, right, because together they equal the entire circle. All right, so that means that angle DAB is labeled as 34 degrees equals 1/2. Arc DCB is X minus arc DB remember the parentheses because we're distributing the negative to the 360 minus x. Right? That means that 34 is 1/2 times, oops, I think I got 2 parentheses in there. Right? So 34 is 1/2 x. I'm going to distribute the negative, minus 360. Negative times a negative is positive, so that's plus x. So that's 34 equals 1/2 times 2x minus 360. Distribute the 1/2. 34 is x minus, well, I don't know why I put parentheses there. I really don't need the parentheses anymore. 1/2 times 2x is just x. Half of 360 is 180. And then add 180 to both sides. And that would give us 214 equals x. Any day now. Right? And then if this problem had said to solve for dB like it originally said, right, let's solve it one more time. But then let's switch it up and solve for dB. So if we're solving for dB, then this is going to be the 360 minus x. And this one will be the x. It's easier to have what you're looking for be the x. Right? So now if we're solving for dB, it would look like this. Still be 34. And it would be 1/2. The large arc is now marked 360 minus x. The small arc is now marked x. And notice you don't need the parentheses because you're not distributing a negative to 2 terms, just to 1. And that would give us 34 equals 1/2 times 360. Negative x times negative x minus x would be minus 2x. We can distribute the 1/2. So 34 equals 180 minus 2x. We're going to subtract the 180 from both sides. I'm running out of space. I'm going to just go over here. All right, so 34 minus 180 is going to be 146 equals negative 2x. And then, negative 146, right, because we subtracted a larger number, equals negative 2x. Divide both sides by negative 2. And then we get 73 equals x. And let's see. Oops, did I make a subtraction error? Because 214 and 73 does not add to 360. Did I make any errors? That one looks okay. 34, I distributed the 1/2. We added 180 to both sides. Not seeing anything wrong with the 214. All right, let's see. 34 equals 1/2. 360 minus x. Looks okay. Distributed the 1/2. Oh! Now I see it. I only divided one term by the 1/2. So that should have been, 1/2 times 360 is 180. 1/2 times negative 2x is just x. All right, so you don't even have to do a formal check, but look at your answers. They should add up to 360. And then we could see that wasn't going to add up to 360. All right, let's try that again. All right, so now we get negative 146 equals negative x, and that means 146 equals positive x. Now, does 146 and 214 equal 360? Yes, it does. So this time we just did a check by solving for both of them. All right, but I wanted you to see what to do if you're solving for the large arc or if you're solving for the small arc. Okay? Now, if you're asked to find both arcs, you don't have to solve twice. Just plug in whatever. So just plug in the 214 in for x. Right? And that would have given you 146. Right? Or if you solved for dB and you were looking for the other one, the dCB, again, you can just plug in 360 minus 146, and you get the 214. All right? But it usually helps to put an X on the one you're solving for. Right? Let's kind of hurry and finish up the rest of these. And going past this one, just waiting for it to turn. Any day now. This one's already done. Skipping that one. And how about the next one? So if there's already the answer on there, I know that we either did it in class or I did it on the Nearpod, like that one. Right? That one was already done. Move on to the next one. Or this one wasn't in your notes and I couldn't tell. But I think we did this one in class. All right, so here's the next one that we need to do. All right, so here we need to find the small arc, but if you look, 163, 55, 108, and that small arc together, they're making up the entire circle, right? No part of that circle is neglected. And if we add the three arcs plus an X, add the four arcs together, set it equal to 360. Right? The three arcs that we know the values of add up to 326. Subtract 326 from both sides. Our missing arc is 34 degrees. All right, so we now can find angle 1 here. Same formula. It doesn't matter whether it's two secants, two tangents, or a secant and a tangent. If the angle's outside the circle, it's 1/2 large arc minus small arc. And the large arc is always further away from the angle. So the large arc is the 55. The small arc is the 34. The one with the larger number is going to be the larger arc, of course. And this is a really easy one. Angle 1 equals 1/2. 55 minus 34 is 21. And half of 21 means that is 10.5 degrees is the measure of that one. And this one was in the notes. Right? Let's go on to the next one. And it's coming up any moment. Maybe I should start trying to change the page. I don't know if it would be happy with me changing the page while I'm writing. All right, so this one is in your notes. All right, so we don't have to do any solving to do this one. This is the large arc. We know that measure. This is the small arc. We're looking for that measure. And the angle. We know the angle measure. So the angle is 1/2 large arc minus small arc. That means that 80 is 1/2 185 minus x. Now here, neither of those are easily divisible by 1/2. It would make more sense to just multiply both sides by 2 and get rid of the 1/2. So long as you do it to both sides, it's fine. You can do whatever you want. All right, so 2 times 80 is 160. 2 times 1/2 is 1. That means that on this side we just have 185 minus x. We'll subtract 185 from both sides. We should get a negative number because the x is negative. That'll give us negative 25 equals negative x. Divide both sides by -1, and 25 degrees is our missing arc. Right? And if we were to check, I'll just do a quick check on this one just so you can see how to do the check. So to check, you just plug it back in. 80 equals 1/2 185 minus 25. 185 minus 25 would give us 160, and half of 60 is indeed 80. That checks out. All right. That's all there is to a check. Just plugging back and making sure you got the same thing on both sides. And waiting very patiently for the next one to come up. All right, this one I already did in the Nearpod, I believe. All right, so it doesn't matter if it's a secant and a tangent, two secants or two tangents. All right, the angle is equal to 1/2 large arc minus small arc. Let's go on to the next one. I think there's maybe 2 more in your notes. This one we already did on the Nearpod, right? So this one was covered. And if I'm wrong, I'll go over it in class. I'm pretty sure that I covered that one on the Nearpod. And here's the next one. This one is in your notes. All right, so large arc. It's actually a really easy problem. It says challenge problem. Not really, because we don't really have to do much. We have the large arcs labeled, the small arcs labeled, the angles labeled. So it's just angle A is equal to arc, the large arc, 1/2 of the large arc, which would be arc BC, minus the small arc, which is arc DE. Right, so angle A is 40, equals 1/2. The large arc is 7x, small arc is 3x. We could simplify that. 40 equals 1/2. 7x minus 3x is 4x. Right, and no reason to multiply by 2 because we can take half of 4x. Nice pretty number, 2x. So 40 is 2x, and then divide both sides by 2. So 20 is x, and that means that the measure of arc BC is 7 times 20, or 140 degrees. The measure of arc ED, or DE, whichever you like, DE, is 3 times 20, which is 60 degrees. Let's check this one. Right, so that would be 40 equals 1/2, 140 minus 60. I'm just plugging the numbers in, right? So 40 is 1/2, 140 minus 60 is 80, half of 80 is 40. So that does check out. So we can feel pretty confident on this problem. So it really wasn't very challenging. I think it took me 2 minutes. I think this is the last one. Coming up. I think I've got one more. This one, I couldn't tell because it was not in your notes whether I completed this one. Right? So I can go over this one in class. But actually, this one wasn't really too difficult. You just had to find the value of y. If you add up 5y plus 2y plus y, right, you get 9y. So the whole circle is 360 degrees. Divide by 9, and so that makes y equals 40. And then so the large arc would be 5 times 40, or 200. The small arc was 2 times 40, or 80. And then to solve for x, it's just large arc minus small arc. Half of large arc minus small arc. So that means x is half of 120, or 60. Right? So this one wasn't really too difficult either. It just looks like a challenge problem because it's got x's and y's. But use the y's to solve for the arc measures, and then you can solve for x, the angle. And this is the last one coming up here, and it's also in your notes. All right, and again, angle equals large 1/2 of large arc minus small arc. Of course, the 30 is the small, the 4x plus 50 is the large. Right, so 3x equals 1/2 of 4x plus 50 minus 30. We'll simplify. 3x equals 1/2. 4x, 50 minus 30 is 20. We can just easily distribute that 1/2, so let's do so. 3x equals 2x plus 10. Didn't forget to distribute the half to both of those terms. Subtract 2x from both sides, and x equals 10. All right, so now let's check this one. Let's find the arc measures. So large arc is 4 times 10 plus 50. That's 40 plus 50, or 90. The small arc is known, that's 30. And the angle is 3 times 10, or 30. All right, let's check. And here's the check. Really should use 2 different colors, huh? Looks like a sea of red. All right, check. So we have 30 equals 1/2 90 minus 30, right? Angle equals 1/2 large arc minus small arc. 90 minus 30 is 60. Half of 60 is 30. This one checks out. And I finished right before lunch ended. Thanks for watching. That's the end of this podcast. Bye for now.